aurora, also commonly known as the northern lights or aurora borealis in the northern hemisphere and southern lights or aurora australis in the southern hemisphere, is a natural light display in Earth's sky. Auroras are the result of disturbances in the magnetosphere caused by the solar wind. Major disturbances result from enhancements in the speed of the solar wind from coronal holes and coronal mass ejections. These disturbances alter the trajectories of charged particles in the magnetospheric plasma. These particles, mainly electrons and protons, precipitate into the upper atmosphere, thermosphere, and exosphere. The resulting ionization and excitation of atmospheric constituents emit light of varying color and complexity. The form of the aurora, occurring within bands around both polar regions, is also dependent on the amount of acceleration imparted to the precipitating particles. The colors and wavelengths of auroral light vary according to where you view them. Red is seen at the higher altitudes. Excited atomic oxygen emits a low concentration of atoms, and lower sensitivity of eyes at this wavelength make this color visible only under more intense solar activity. The low number of oxygen atoms and their gradually diminishing concentration is responsible for the faint appearance of the top parts of the curtains. Scarlet, crimson, and carmine are the most often seen hues of red for the auroras. Green is seen at lower altitudes. A fairly high concentration of atomic oxygen and higher eye sensitivity in green make green auroras the most common. The excited molecular nitrogen, atomic nitrogen being rare due to the high stability of the N2 molecule, plays a role here, as it can transfer energy by collision to an oxygen atom, which then radiates it away at the green wavelength. Red and green can also mix together to produce pink or yellow hues. The rapid decrease of concentration of atomic oxygen below about 100 km is responsible for the abrupt-looking end of the lower edges of the curtains. Blue is seen at yet lower altitudes. Atomic oxygen is uncommon, and molecular nitrogen and ionized molecular nitrogen take over in producing visible light emission, radiating at a large number of wavelengths in both red and blue parts of the spectrum. Blue and purple emissions, typically at the lower edges of the curtains, show up at the highest levels of solar activity. The molecular nitrogen transitions are much faster than the atomic oxygen ones. Ultraviolet. Ultraviolet radiation from auroras within the optical window but not visible to virtually all has been observed with the requisite equipment. Ultraviolet auroras have also been seen on Mars, Jupiter and Saturn. Yellow and pink are a mix of red and green or blue. Other shades of red, as well as orange, may be seen on rare occasions. Yellow-green is moderately common. As red, green, and blue are linearly independent colors, additive synthesis could, in theory, produce most human-perceived colors. Auroras change with time. Over the night, they begin with glows and progress towards coronas, although they may not reach them. They change in a few minutes from quiet arcs all along the auroral oval to active displays along the dark side, and after 1 to 3 hours they gradually change back. Changes in auroras over time are commonly visualized using kiograms. At shorter time scales, auroras can change their appearances and intensity, sometimes so slowly as to be difficult to notice, and at other times rapidly down to the sub-second scale. The phenomenon of pulsating auroras is an example of intensity variations over short timescales, typically with periods of 2 to 20 seconds. This type of aurora is generally accompanied by decreasing peak emission heights of about 8 km for blue and green emissions and above average solar wind speeds. They are predominantly seen in high-latitude regions, especially around the Arctic and Antarctic. Auroras display dynamic patterns of brilliant lights that appear as curtains, rays, spirals, or dynamic flickers covering the entire sky. Most auroras occur in a band known as the auroral zone, which is typically 3 degrees to 6 degrees wide in latitude and between 10 degrees and 20 degrees from the geomagnetic poles at all local times or longitudes, most clearly seen at night against a dark sky. A region that currently displays an aurora is called the auroral oval, a band displaced by the solar wind towards the night side of Earth. Both Jupiter and Saturn have magnetic fields that are stronger than Earth's. Jupiter's equatorial field strength is 4.3 Gauss, compared to 0.3 Gauss for Earth, and both have extensive radiation belts. Auroras have been observed on both gas planets, most clearly using the Hubble Space Telescope, and the Cassini and Galileo spacecraft, as well as on Uranus and Neptune. The aurorae on Saturn seem, like Earth's, to be powered by the solar wind. The word, Aurora, is derived from the name of the Roman goddess of the dawn, Aurora, who traveled from east to west announcing the coming of the sun. Several stories are told about the aurora. A common one told to children is if you wave at the aurora it will reach down from the sky and take you away. The Chavas Indians believed an expectant mother would give birth to a boy. In Japan it is said a proposal under the lights would lead to a happy marriage. To the Sami people it is said to be a contact for spirit world. The aurora may also appear in the form of an animal, such as the firefox. The naked eye will not always perceive the full intensity and beauty of the aurora. The best way to view the northern or southern lights is with a camera. A manual setting is always recommended. What do you get when Sleeping Beauty gives a lecture on the northern lights to the people of Wonderland? Aurora Borealis.